The next one is yes, a paper of Andrea Celli, and he has the same problem like many Italians. Fortunately, I'm not Italian in this kind. It's a little bit better. I have some problems too, but not so much. And
I am confused also in Italian. In English, it's better to avoid.
You are speaking. Your English is good.
Oh yes, I thought we didn't have the slide rules.
Non so se però è ultimissima, lui me ne ha mandata una.
Se si dà la parola di
È questo?
È la mia chiavetta.
Okay. Let's say I have to read his elaboration, and I think it will be understand. We have the first slide rule. Andrea Celli is here, is the author of, and he worked the last day in the IAC. This is a really historic research center. It's like the DFG in Germany, an institution of the numerical calculation, statistics and so on. It's already founded in 1927. A very famous professor there founded it. It was very, very important in Italy. Facciamo il secondo. A short story of Italian production of computing tools. Yes, everybody perhaps knows, it's very sad because at the beginning of the 20th century there was almost no production, no Italian production, almost nothing. They had some, yes, let's say adding machines, but later on only produced in the late 30s during the fascism, with the goal to be autarkic, but it's not function not very well. For slide rules, it's a little bit better. Some industries existed. Some of them developed interesting devices, but never had a role in international market. There will be presented some Italian slide rules, which are interesting in original ways. The problem of long scales in small devices. Long scales in small devices. Perhaps one you have already said, the small zipper. We will go in detail for this. And the other kind was the slide rules, or the rules, or the tables, the automatic tables for reinforced concrete. Very interesting class of Italian products. Next. In 1910, a German magazine announced a new dream calculator made in Italy, performing 4 operations and printing data, and the result. This seems in contrast to this what I was saying, but next, it was a joke. Really, they took the Italian for a little fool. Italy was chosen because the only, let's say, European country without factories producing calculating machines. There was some Italian machines, but made in France. Not so important. Next slide, please. In 1932, it was founded Primo Stabilimento Calcolatrice Italiano, in English, first Italian factory, calculating factory. Interesting, this is the machine, the Logistea, interesting small pinwheel machine. I don't even know if it's really a pinwheel machine. I didn't control all this. In the same year, there was other foundings of Alfa Inzadi. Then we have the name Duconta Numeria, perhaps you heard. Of course, Olivetti, Jim, and there are some factories not very known, but you find it printed on the calculators. Till the World War II, there was not very much production. and this began next year. Only after the war, there was a really big, let's say, a big boom of production. Of course, it was Olivetti. Not alone, this was Everest, Lagomarsino, they more sold only machines, but produced some Inzadi, Aldobono, Alpha, and some other products. And till Olivetti became the first production of calculators in Europe, the exporting to all the countries with the most famous machine, Divisumma 24. This was a big boom also for Olivetti, because the production cost was only about a tenth. They said to me a tenth of the market price of the price. Yes, perhaps it's interesting. The next we have the yes. Yeah. Let's call not so much about this. We take the slide rule projection. For slide rules, it's interesting because only in the 1856 there was some introduction of slide rules with a nice book and so on, but for some reasons, not very echo, not really a big production.
The most feedback we got on Seller was 10 years later with a French edition. That's the German edition. And a lot higher circulation. Nobody looked at the Italian.
Yeah, in Italy, perhaps there was not the let's say the idea that this kind of calculus would be important. Perhaps it was more important to calculate by hand or something like this, and not so technically. Another person is Ignazio Porro. Was in fact was an optician, but he is linked to optical inventions. But he founded a firm, this Filotecnica Salmoiraghi and Tecnomasio, two companies that produced some kinds of different kinds of calculating and measuring devices and slide rules too. Yes. Andrea says they made good slide rules. I don't really know about this. We go ahead. Perhaps it's interesting the other. Yeah, of course. None of these countries really played a real role in the world. Perhaps was interesting still Marcantoni. This was practically a product of slide rules, more for, I know, of military reasons, for the angle of the yes, for the ballistic calculations, let's say. Artillery. Thank you. And then was Filotecnica, Salmoiraghi, and they produced different scientific instruments, sewing machines and so on. Another was Salmoiraghi Vigano, but now it's another chain of spectacle shops spectacle. Yeah, all the others, they are known here. I myself don't know about this and won't not speak very much about this. In 1881, person, Alberto Castigliano, presented a slide rule. We go ahead. Presented a slide rule called Nuovo Arithmograph, New Arithmograph, and it was made in this when we remember at the same time at Thatcher's patent, Thatcher, the known Thatcher. Of course, both made a long slide rule cut in different pieces, let's say, Thatcher and also this Castigliano. And this 1 meter scale cut in 25 parallel segments. And, but essentially it was not so like the Thatcher, it was essentially a Gantt scale, a Gantt not scale, rule, let's say, and you had to with a compass to do the summing of the logarithms. Guardiamo avanti. Come funziona? Allora, praticamente sono andati due, può andare indietro un attimo?
No, manca, vabbè.
Ah, manca. It's not so. Essentially, the functioning of this Castigliano was like a Gantt, but you had to adjust in each cut. You have to adjust 2 slides, one for the first point and for the second, and then going ahead. It's like a simulated compass. You do it with the Gantt rule. Yeah, perhaps I explained it enough for the experts. A little bit similar was this Microcalcolatore about 70 years later, and but we and Andrea, we really don't know exactly how it's working, but perhaps with the help of Professor Klein, we can see a little bit more. It's inside this microcalculator. This is like a small zipper. You have to have a look there. This is very interesting. Very rare item. I think it's only one existent for the moment. It's like a metal block, and inside there is a long tape. Let's say a long tape, and turning. You can turn it like with the rule over there to turn it, and you can fix the beginning and the end. It's something similar like a compass. A compass fixing the beginning, going ahead, reading the end, and this is the result. But the reading is, let's say, a little bit difficult because you have to have a lens, and to look there, even with the lens, you see it very, very small, let's say. But it's very portable, let's say. It's surely the best treasure to be found for a collector of these items. Yes, let's go ahead. Yes, here is some explanation. Perhaps I won't read this. There are different scales microphotographed on this tape, and the lens, yes, powerful, is it is a small lens. It's like half a centimeter in diameter, but the functioning is like a Gantt rule. Yes, go ahead. Another product is interesting. This is a projection slide rule. It's perhaps the idea is similar. It's much bigger, and perhaps we can have a look. Andrea has brought the product. It's it's a tape, and but with a projector, and you can turn. One can turn, but the function is very similar to the it's very similar to the zipper I spoke about. Yeah, this is
well, it does not follow. It's a sign C.
Yes, you can here see the scale.
A scale.
Yes, and
L scale.
Here, see
okay, and it's like a long slide rule. You see the parts which are interested in.
Yeah.
Interesting product. One has to look at this, and perhaps an expert can see more than explanation, a verbal explanation.
1950, huh?
That's, it's in the 1950s.
Yes, they only made a few.
What?
They only made a few.
Only made a few. Oh no, so pocky. Yes, it's perhaps the reason.
I don't know if it was in the catalog of Filotecnica, but actually I know 4 of this rule in the world. Other maybe existed now.
Yeah, it's written down in the JOS.
Inventor of this rule is the same of inventors of the previous rule, the zippo rule.
This is the same technology.
But it's the same person.
Let's go ahead. You have to see. This is some of the explanation of this different scale.
Yes.
There's an optical system which zooms on these scales. Yes, very simple to use. Yeah, of course. It's a simulated slide rule. When we have simulators on the computer, there's not much difference. But because on the computer you can have a high resolution and you can zoom in the viewpoint to the part. Let's go ahead. Yeah, here's another. The publicity of
This
this
is page from the catalog.
from the
That
catalog.
is the page of the
Vai avanti. Another interesting series of products are these these, let's say, calculators. These are different. These are not really slide rules. These are disk and automatic tables for concrete for the production of reinforced concrete, iron and concrete, the mixing, because yes, I don't know if it was because in Italy it was difficult to have the products, iron and so on, but it's interesting that the production was mainly perhaps in Italy, or perhaps this was the professor, this professor Sabatini, who did theoretical work on this combination of iron and concrete to product bridges and edifices and so on. He made different approaches. Made different approaches. Yes, this is one of these Marcantoni. I said before, it's a general slide rule. For special case, I don't know. Let's go ahead.
concrete.
Yes, it's for concrete, but it's more interesting is this from Ferrero. This is the collaboration with this Professor Sabatini.
No, this is Ferrero himself.
Ah, it's himself. Oh yeah, later on they work. Oh yes, this is let's say a multiple slide rule. You have to substitute several slides in the right thing to have something like, let's say, here is I don't know exactly, but you have how much iron and the percentage and so on, and you for some, let's say, construction element, you can read on some scale the composition, the size, how big it can be to support some stress, the right stress. But seems, I think it's very interesting. He brought it with him. It's over there. You have to have a look at it. It's very complicated. Unfortunately, we really don't know how it works, what we have to calculate. Perhaps Ed could help us a little bit, but we are not a construction specialist.
Pretty sure he's a structural engineer, so I imagine that.
And in that, yes. But this is we see it as a problem to the future because this Ferrero and the other people, this Sabatini, Washington Sabatini, made some approaches to resolve the same problem. Let's go ahead. This is one, the first Washington Sabatini model EF. This is essentially, this is not a really slide rule yet. They're sliding something. Inside are two big drums with numbers, and you can read the numbers on these small lenses here, and turning the knobs here, you can turn inside and go. I have it over there. You can have a look. Unfortunately, we don't know what is the really meaning. We see the numbers, but cannot calculate something. I have brought the one product which even has had other scalings inside for French, because there was a French for French makers, and this is perhaps Italian, but the French tables, the French tables were worn about, this broke apart, and there remained only the Italian beneath. That was very interesting. But you can see the thing over there. Here you see the two drums, and they turn when you turn the knob over there. Yes, another one is this is I think this is my presentation I did in the Rechnerlexikon of mine. A little bit the same. What is called the Washington G. Inside there is, where is the drum? Yes, here. Inside it's open. There's a drum, simply with a lot of numbers, and you can read when you turn here. When you turn here, this lever here, you can read inside at the right position. I don't know what is the right position. The right position, some numbers for see the combination. And with these levers here, you can take it up and slot in some rings here to have the possibility to turn only a part, let's say. The real functioning of this is a little bit obscure.
May I give you a short explanation how it works?
Yeah, you can do it.
I don't have some more civil engineers, but I'm civil engineer.
Oh, yeah.
I have this box at home.
Oh, yeah.
It took me days before I understand how it works. But in general, you have each country has its own concrete codes. That's meaning that all the concrete slides rules for the different countries are different because the factors are different. Very simple. If you have a beam, you put a load on it. It gets some what we call a moment in it. And you have to try to translate it to the stresses in the concrete and in the steel. It has to do with the dimension of the beam. all those positions are indicating the different dimensions of the beam, the different quality of the concrete, and the different quality of the steel. And this one here, the small one here, you get the difference if it is a hinge, two-sided hinge, or one that is a fixed end and a hinge, or you get two fixed ends and you get different formulas in. So in this small scale you have to figure out what is your specific loading case, and in the other scales you give the loads, dimensions, the concrete quality, etc., etc. And if you put them on the right positions and you turn it several times around, then you find here in the small scale the amount of steel you need in square millimeters mostly, what you have to put in a concrete beam. Long story, very short.
This is very, very.
But that's
May I ask you, did you ever do some publication of this or paper, or is there a?
I have put something once.
I have the manual.
I have
No, the manual. We have the manual, but
I think in Spanish and in English. I think the best introduction to that still is Van Broen's article in the Aristo book, where he took several well-known slide rules for reinforced concrete, and he put them under stress and under pulling, and these links here for the Nestor, for the wedge, etc. And I think that's a good introduction.
Yes, and Paul from our Belgium professor.
Van der Molen.
Van der Molen,
That's what I meant.
he has compared about 30 different slide rules
Yeah.
for concrete.
Yeah,
oh, this is a lack of knowledge. We have to.
I have put
fill in.
all the tables on the small publication in the EM, I don't know, 2007 or 2003, I've written something about it. So there's some all documentation about it. I can send it if somebody wants it.
Yeah, I just have one comment about that. I'm also a civil engineer, and I learned in the late 1950s how to design things from concrete, from reinforced and pre-stressed concrete, and in the United States. And the way we did it was without anything like this. So we had ordinary slide rules, solving simultaneous equations, and maybe log tables sometimes, but never anything. Never a dedicated slide rule that I know.
No, I never use it.
I worked for two of the largest highway departments in the United States, and designing bridges.
Francisco, can you go one or two pictures back? I show you something. One more back. This one here.
Yeah.
If you have those curves here, they mostly have to do with the quality of the steel. So you make the choice of the quality of the concrete, and you say I have steel with a high stress or lower allowable, and then you figure out on which of those scales you have to read the diameter of it. The stronger steel, the
Please, excuse me, what contributed to the quality of the steel? That it contains in carbon or?
No. Yes.
Carbon, yes.
In a beam you have compression at the top and tension at the bottom. The tension has to go, to say it simple, in the steel, and you have steel with low allowable stresses and high allowable stresses. And the choice means how many square millimeters you need to put in it as rebar. And the quality of the steel, that is the chemical process, is more carbon, more magnesium, more this, more that, and but that's not a story. But in the normal tables in the construction, you can make the choice of the allowable stresses in the steel. Yeah, and that's often a matter of financing. Yeah. Cheaper steel, more square millimeters, more expensive steel, less square millimeters. That's the game in the industry. Yeah. Okay. Thank you.
I think nowadays everybody has like a smartphone or a calculator. It's doing all these things.
Excel macros.
Excel macros, yeah. Oh,
Yes.
this is not so good.
An amusing thing is the logo. If you observe the logo, in the logo, when it's working with the previous
The previous.
with the previous model, the logo is the second model.
And when we go ahead,
Maybe that was made for George Washington.
No, Washington Sabatini. traceable.
Why some Italian persons are called Washington? Very strange.
This
But
is
there
one-
are other people who were called Washington as a first name.
As a first name.
This had nothing to do with really Washington, DC, and not. Yes, this the same person or the same let's say factory continued a more simplified version. They don't have the big the big drum beneath. I don't know why, but I think it's. You can read here at the outer side what is the result. Let's say this. I brought this is over there. I brought mine because it's not so easy to bring it about. And these partial sectors may be inserted here to have other scalings. Let's say the real use is more mysterious than the other. But it's a very nice instrument, big, and gives a good figure. It's the same functioning than the other. You can pull off these parts to bring different rings in turning when you turn the branch.
Let me ask a question. So we have seen before that Washington was a sort of trademark of machines made by
the person. Yes, Sabatini.
And here I see Ferrero.
Yes, but the production was
Changed
changed.
in 34.
Okay.
I have an advertisement of Sabatini in 33 with Sabatini on Elia by Washington Railroad. I have an advertisement in 34 with Washington Railroad made by Ferrero. On the previous railroad, which this change arrived before the war. After the war, this kind of railroad was always done by Ferrero.
Perhaps we have to look. There is some other slide. Yeah, can you say? Yes, this is another product, a little bit modern, more modern, let's say, from Arici. The functioning, I think it's very similar to other. You have to turn the knobs, and inside there is some scale, perhaps some drum. I don't really know because
Inside there are a lot of gears.
Oh, gears, yes. But no, yes, the gears, of course,
there are
but
3 ear gauges.
yes,
You can move the
you
center,
turn one, and they are connected.
Move the right and the left go around.
Yes.
So in the center, you can choose the dimension of the beam. Now, excuse me. You enter here with the bending moment. And here you can choose the quality of the steel and then the quality of the concrete. I don't remember before. Tomorrow I will display here. Here.
You have brought one?
Yes,
You have
yes. So you decide, you start with the bending moment, decide the kind of steel, and the
Find how much the concrete.
and then here you can, you got the result of the large and thickness of the beam. So you can say I want a beam 20 centimeters large. So here the calculator gives you the thickness. And what else? And you say the steel work by tensile strength and the concrete by compressive. So here you can say how the tensile strength increase And there is a point in the center of the beam, a neutral axis, right, where the compression forces go to 0 and then change the vessels, right? All this machine made in 50 years.
1955.
By architect, Sicilian architect.
Arici. You made a free model. The first model was called T3, was in bakelite. Then Arici 55, and then 68. The model.
I only saw this one.
I seen T3, the bakelite model, but I don't know. I just see it. But general organization of the calculator is the same. I have not.
And then again, at the end, the calculator say you need 50 millimeters squared of steel. So there is a scale where you can choose if you need, I don't know how to say in English,
the rod,
yes, or the wire of steel. If you use a wire of 5 millimeters, you need 10 wire. If you use 10 millimeters, you need 3.
The section of
Yes, yes.
the raw material.
This transparent part can be changed depending of the kind of calculation you wanted to do. I have not carried it to Trento, but I have a huge new, different transparent part at home, use it for a different kind of structure.
Yeah, I just have one other question, because my recollection is things like, for the dimensioning of the beam, does this machine deal with that? There's a section modulus component in the calculation. Has something to do with the first moment and I can't remember now anymore. But does the section, but you have length and width and depth of the beam. You have 3 dimensions.
Yes, yes, of course.
Help you do that calculation?
Yes, yes. It's you have to insert somewhere. There's no in the other instruments the section and the length, of course, of the beam, and independence, as you said, of the rods, of the diameter of the rod. You have to join some rods more, let's say, to have the just the same stability.
And what about pre-stressed concrete?
Yeah.
No,
No, it's not. It's
Yes, yes.
It's only pre-stressed, only. No, also.
Also pre-stressed.
Okay. If someone is interested,
Precomplesso,
No.
Okay.
if someone is interested, can give me email. I send the PDF of instruction. Italian instruction, better for topic.
Yeah, perhaps it's worthwhile to recollect all these knowledges, different knowledges in different parts. We really, perhaps we are lacking some information, you said, but perhaps it would be interesting to do a recollection of all these kind of works. It would be interesting, as you said, how in other countries one worked, and the comparison of this, but perhaps in Italy they wanted to make it more simple directly and not calculate the persons with the slide rules. And one has perhaps to consider that slide rules in Europe in general came very late in Central Europe. English part was different, but they calculated with machines, with technique, with gears and so on. And this is one of the examples. I think we have finished now. Thank you.
Thank you.